Welcome to Introduction to Phonexia Speech Technologies for Voice Biometrics and Speech Analytics. You will get familiar with the individual Phonexia technologies, their functionality and typical usages, as well as the Phonexia Speech Platform architecture. You will also get brief introduction to the main products forming the speech platform: Phonexia Speech Engine, Phonexia Browser, and Phonexia Voice Inspector. And finally, you will see the typical deployments topologies, the data flows in typical implementation use cases, and the technical options for licensing the Phonexia products. Let's get started. The main Phonexia's motto is extract useful information from the speech using voice biometrics and speech analytics. This means that Phonexia technologies can analyze an audio signal containing speech and extract information about who is speaking, like is it a male or female, what is speaker's age, or what language is spoken, and also what is being said, like spot certain keywords in the spoken text or transcribe the complete text. In a dialogue, the technologies can provide information about the dialogue flow, which speaker speaks when, or whether there are parts when both speakers are silent or parts where both speakers speak at the same time. All this information can be useful for various purposes depending on the target market. Based on the market needs, we recognize two market segments: government and commerce. While basic application areas in both segments are the same, voice biometrics and speech analytics, the individual use cases are different. In government segment, voice biometrics is used to identify speakers in crime-related recordings, filtering massive amounts of recordings, searching for speakers in archives, and so on. Speech analytics is used for making recordings archives searchable, understanding the nature and content of massive amounts of audio, spotting threats in phone calls or similar. In commercial segment, voice biometrics is typically used for alerting of possible fraudster calls by comparing the caller's voice against a database of fraudsters, or verifying the caller's identity in the background during the call. And speech analytics is typically used in call centers for automated call transcriptions, for example, to do further analysis of spoken topics, getting the demographic information like age and gender of the callers, or performing agent's quality check by analyzing the dialogues for crosstalks on one hand or long silent parts on the other hand, or checking whether agents follow the required script. For example, if they greet the client at the beginning, offer additional services or products before finishing the call, and so on. And this entire variety of use cases can be covered by Phonexia Speech Platform. What is the Phonexia Speech Platform? It's represented by a server application named Phonexia Speech Engine, driven by a number of speech processing technologies: speaker identification, language identification, gender identification, speech transcription, keyword spotting, and time analysis extraction. The speaker, language, and gender identification technologies are the main part of Phonexia Voice Biometrics, and the speech transcription, keyword spotting, and time analysis extraction are the main part of Phonexia Speech Analytics. These are the two product groups which were shown on the Phonexia Speech Platform overview diagram. Apart from these, there are also a few of what we call supporting and filtering technologies: speech quality estimation, voice activity detection, diarization, and age estimation. Let's talk in more details about what the individual technologies do, how they work, and what they can be used for. Filtering and supporting technologies. Phonexia speech quality estimation is designed to quantify the quality of audio recording to help to decide whether the audio is worth further processing by speech technologies, or whether its quality is not good enough, so processing by speech technologies would give unreliable results. Speech quality estimation measures more than 20 attributes of the audio, like, for example, its total length, length of silence or noise in the audio, or minimal and maximal sample values. It also produces a global score which is based on two most important measures: audio bit depth and signal-to-noise ratio. The technology is extremely fast, so it's generally recommended to use it at the beginning of the processing chain as part of what we call rapid filtering. Phonexia Voice Activity Detection analyzes audio recording and identifies which parts of the audio do contain speech and which parts don't. This information can help to decide whether the audio is worth further processing by speech technologies, like whether it contains any human voice at all, or whether the speech is long enough for being processed further. Other typical use is to filter out non-speech parts of the recording. Voice activity detection can process also real-time audio streams, so it can be used for voice-activated processing. It can listen silently to a continuous audio stream and activate some process only when a voice activity or a long enough voice activity is detected. Voice activity detection is usable universally as it does not depend on the spoken language or on the acoustic channel. It's also very fast, so it's recommended to be used together with speech quality estimation for initial filtering at the beginning of the processing chain. Phonexia Diarization can identify which parts of a mono audio recording are spoken by the same voice, plus also identify segments containing silence and segments with some technical signals like DTMF beeps or similar. This makes diarization ideal for pre-processing audio for other speech technologies, like splitting mono recording to multiple audio files containing individual speakers, detecting number of speakers in the recording, or labeling recordings by speakers. Diarization is, similarly to other supporting technologies, not dependent on spoken language or acoustic channel. Diarization comes in more variants called models, differing in processing speed and accuracy. A fast but less accurate model and more accurate but slower model. This allows flexible implementation according to particular requirements. Phonexia age estimation estimates the age of a speaker in audio recording. It's trained on a wide variety of audio sources, so it's not dependent on spoken language or accent, spoken text or acoustic channel. Similarly to other technologies, age estimation comes in more variants called models, differing in processing speed and accuracy, a fast but less accurate models and more accurate but slower models. Phonexia Waveform Denoiser is designed to remove various kinds of noise from audio recording and enhance speech signal in order to help human operators actually physically listening to the recordings. It's not primarily designed to help other speech technologies. However, depending on specifics of particular kind of audio files, it may positively affect results of speech technologies too. But this is by no means guaranteed and must be tested. Waveform Denoiser is neural network based and is provided in separate language specific models. Voice Biometrics technologies. Phonexia speaker identification is a technology for identifying a speaker in audio recording. It works in two phases, an enrollment and identification. In the enrollment phase, a sample of speaker's voice is collected and so-called voice print is created. In the identification phase, a voice print is created from a speaker's voice in the audio recording compared to the enrolled speaker's voice print, and a match score is produced. Speaker identification has a wide variety of usages, from identifying whose voice is in this recording, through searching in which recordings is speaker XY speaking, or spotting, hey, it's speaker XY speaking in this recording, to verifying, yes, it's really speaker XY speaking in this recording. Speaker identification is, similarly to other supporting technologies, not dependent on spoken text, spoken language or dialect, or acoustic channel. Speaker identification can process also real-time audio streams and comes in more variants called models, differing in processing speed and accuracy, fast but less accurate models and more accurate but slower models. Phonexia language identification can identify the language or dialect spoken in an audio recording. It can be used as filtering technology to simply filter out recordings not in the language of interest. Other possible use cases for language identification are call traffic language coverage analysis, routing calls to appropriate human operators, like for example in multilingual call center, or routing calls or forking audio recordings processing to language-dependent technologies like speech transcription or keyword spotting. Similarly to other technologies, language identification comes in more variants called models, differing in processing speed and accuracy, fast but less accurate models and more accurate but slower models. Phonexia gender identification can recognize gender of the speaker speaking in an audio recording. It can be used for filtering or routing, for example in call centers, calls by gender, creating demographic analysis, or targeting advertisement to specific genders. Gender identification comes in more variants called models, differing in processing speed and accuracy, a fast but less accurate model and more accurate but slower model. Speech analytics technologies. Phonexia speech transcription transforms speech signals to plain readable text, which can be further easily edited, searched, or processed by text-based data mining tools. It's typically used for topic detection by analyzing content of call traffic, audio content data mining and indexing for search purposes, or storing the content of phone calls or audio for archiving purposes. Speech transcription works not only with speech acoustics, but also with dictionary of words and their pronunciations. This means that it depends on language and dialect and can recognize only words present in the dictionary. Speech transcription is also capable of processing real-time audio streams. Phonexia keyword spotting can detect whether a keywords or phrases have been spoken in an audio recording. This has a wide variety of usages. For example, in call centers, it can be used for checking for inappropriate language or checking if operators follow their script. Keyword spotting can be also used for searching media or calls archives for specific content or trigger security or defense alarms based on call content. Keyword spotting works only with speech acoustics. It takes the actual pronunciation as an input, which means that it's not dependent on any language-specific dictionary. For any keyword or phrase, an unlimited number of alternative pronunciations can be used. Users can specify pronunciation either manually or get it using a supporting technology, the Phoneme Recognition. Keyword spotting is also capable of processing real-time audio streams. Phonexia Phoneme Recognition is a supporting technology for transcribing audio recordings to phonemes and is provided as part of the keyword spotting technology. It is used for getting a pronunciation of a certain words or phrases in a notation required as an input for keyword spotting. Phonexia time analysis extraction can provide information about the dialogue conversation flow. It is typically used in call centers for identifying operators' long reaction time, crosstalks, or both parties talking at the same time. By the nature of time analysis extraction, it can work only with two-channel audio. Time analysis extraction is also capable of processing real-time audio streams. Now, when we have talked about the individual technologies, let's look at the entire Phonexia Speech Platform architecture. Technologies built using a C++ SDK form the solid base providing internal C++ API. There are command line applications used for integration to Linux or Windows scripts. There is also one specialized GUI application for forensic experts called Phonexia Voice Inspector. There is a Phonexia Speech Engine, our flagship product, which is built on top of the C++ API base layer and provides public REST API. On top of the REST API, we have built a demo application called Phonexia Browser. Phonexia Speech Engine. Phonexia Speech Engine is Phonexia's flagship product. It's a server application where all the individual speech technologies mentioned in the previous overview are accessible and controllable via a unified REST API. The REST API can be used from a client's custom-built application. This can be, for example, a lightweight web application or a desktop application like the Phonexia Browser demo application, or any other technology capable of working with REST API like curl or similar. Here are some very brief speech engine characteristics. It can process both audio files and real-time audio streams. Results are produced in JSON format by default and optionally also in XML. It runs on 64-bit Windows and Linux. It's highly scalable. Since each speech engine can be considered a separate computing unit, the audio load can be routed to different computing units using a load balancer, or computing units can be dynamically brought up and down as needed. It can use either an own built-in SQLite database for caching the results, or can be integrated with existing MySQL database if it's already used on the partner's side. The REST API documentation is included in the distribution package and is also available online. It contains complete description of the REST endpoints, their required parameters and return responses, and also some step-by-step example to get you quickly started. End-user applications. Phonexia Browser is one of the Phonexia's end-user applications. It's provided as a demo application as an example of what can be built on top of the Phonexia Speech Engine. Phonexia Browser can either connect to remote Speech Engine or use Speech Engine running on the same machine as Browser. This makes it a pretty useful application for first evaluation or various testing during technology deployments. Browser aims on rather expert-level users. It does not provide any advanced analytical functionality. The process is pretty simple. Upload the files to be processed to the server, then select the technologies to be applied on the uploaded files and let the files be processed by them. Results for each applied technology can be then viewed separately, as for example the speech-to-text transcription on this screenshot. Phonexia Browser is, as other Phonexia products, provided in 64-bit Windows and Linux versions and comes with a detailed manual describing the available functionality. Phonexia Voice Inspector is a tool for police forces, law enforcement agencies, or forensic experts aiming at helping them to compare and analyze recordings and automatically recognize speakers by using the power of voice biometry. Voice Inspector provides many useful features like Phoneme Recognizer for searching and visualization of identical phoneme sequences across audio files, a powerful waveform editor with spectrum panel or voice activity detection, or a speaker identification evaluation tool with graphical output, a detection error trade-off plot, false acceptance false rejection plot, and probability density function plot. Voice Inspector comes also with a simple management of investigation cases and runs on Windows and Linux. Phonexia Products Deployment. As already mentioned, Phonexia products support 64-bit Windows, both server and desktop editions, and 64-bit Linux operating systems like Ubuntu, CentOS, Fedora, Red Hat, and others. Creating custom builds for other platforms can be discussed individually. These operating systems are supported on physical machines as well as in virtualized environment. There might be a slight performance drop in the virtualized environment, so it's recommended to do a performance tests in deployments with expected high loads, like hundreds of thousands of calls per day or so. We recommend using Intel CPUs and have a good experience with Xeon E5 version 4. For less demanding tasks, Intel Core i7 family CPUs can be also a good choice with reasonable price-performance ratio. An example of typical hardware configuration would be two Intel Xeon E5 2680V4 14-core processors with 64 GB of RAM and 500 GB of storage. We recommend SSD because of their high reading and writing speeds. Here is an example of a typical deployment topology using single speech engine. The bottom part of the scheme shows which components are provided by Phonexia, the speech engine, and eventually also the Phonexia Browser as an expert level application. The top part of the scheme shows the main part of the deployment, which is provided by the partner or integrator. The central application, which takes care of the following: handles recordings coming from various sources, stores them on a file server, handles registering or uploading of the recordings to speech engine, handles further processing of the recordings by the speech engine and storing of the results in a database, and provides additional analytical layer and presents the results to users, for example using a web-based interface. For high input load deployments, the topology can be similar, with added load balancer feeding multiple speech engines. Typically, each such speech engine has the same technology's configuration and serves the role of a computing unit, providing the brute force for parallel processing of the input load. These computing units can be brought up and down dynamically to handle peaks and valleys, for example using Docker, and orchestrated, for example using Apache Kafka. Phonexia products implementation. Natively supported formats of input audio files are WAV container with unsigned 8 or 16-bit or floating point 32-bit PCM, ALO, MULO or ADPCM format, raw audio data of the same formats, FLAC format in a FLAC container, and Opus codec inside an OGG container. Other formats need to be converted to some of the supported formats, for example using the freely available FFmpeg or SOX tools. A note about the popular MP3 format. In general, this should be fine as long as the sampling rate is at least 32 kilobits per second. Lower sampling frequencies cause a loss of important parts of the speech information and may cause worse results from the speech technologies. This is because the MP3 compression is designed for human ear. It eliminates parts of the audio signal which are not important for human ear but can be important for speech technologies. Converting MP3 to WAV does not help, since the original information is already lost by the compression and cannot be recovered by converting back to WAV. Therefore, it's generally recommended to use recordings as close to the source as possible for processing by speech technologies. Speech engine supports also real-time audio streams transferred over RTP or HTTP protocols. For RTP, the supported payload types are single channel 8 kHz ALO or MULO, single or dual channel 44 kHz 16-bit PCM, and single or dual channel 8 kHz 16-bit PCM. For HTTP, the supported format is raw signed 16-bit PCM audio. The sampling frequency and number of channels is specified during the REST request. More details about real-time stream processing can be found in the REST API documentation, which provides detailed instruction with examples of opening the stream, sending the stream data, processing the stream data, ways of getting the results, and closing the stream. Typical implementation from data flow perspective in speech analytics. Here is an example of one of the possible speech-to-text transcription data flows. The daily load of data, which can be either recordings from file storage or a real-time audio streams, goes to Phonexia Speech Engine, which detects the language spoken in the audio and transcribes the audio to text. Plus, an additional information like the gender or age of the person speaking can be extracted. The transcribed text and all additional metadata then go in a machine-readable format to a partner solution, where the input data is analyzed and results are presented to end users in a form of reports, for example in a web-based application. The partner solution can also gather feedback from the end users, like for example corrections of incorrectly transcribed words or words not transcribed at all. This feedback can be used for so-called language model customization, where the speech-to-text language models, or let's say vocabularies, are enhanced using this new data and can improve the further transcription results. Here is an example of speech-to-text combined with keyword spotting data flow. It's similar to the previous use case. Again, the input recordings from file storage or real-time audio streams go to the Phonexia speech engine, which can detect presence of certain keywords in the speech, transcribe the audio, and analyze the timing of the dialogue flow. Data from speech engine is loaded into partner solution, which provides end users with analysis and reporting tools, allowing them to read the transcription, see the occurrences of detected keywords, for example directly in the transcribed text or on a dialogue timeline, listen to the audio with the transcription visualized in real time, and so on. Again, the partner solution can allow its users to provide feedback like correction of transcribed words or phrases, or edit the list of keywords to be detected. This feedback can be used for improving the speech-to-text and keyword spotting technologies to provide more accurate results in the future. Typical implementation from data flow perspective in voice biometrics. Data flow in voice biometrics applications usually differs from flow in speech analytics, especially in the government sector. The target calls, usually in the form of audio files, go through the step called rapid filtering first. This step includes speech quality estimation and voice activity detection, which rule out recordings not reaching the call quality and speech amount criteria. The recordings which pass through the rapid filtering are then processed and compared to the reference voice prints from archive. At the same time, the new recordings and created voice prints are also archived. Comparison results are presented in a list of found matches sorted by the match score. A human operator then can listen to selected recordings, for example to recordings with a match score higher than a certain threshold, or to a number of recordings with the highest match score, called N-best. Another possible output of the comparison is so-called evaluation report, which is used to evaluate the performance of speaker identification system. Let's look at the technical side of the various license types available for Phonexia products. Phonexia licenses can be provided in the following ways: USB license bound to USB dongle, hardware license bound to machine's hardware profile, network license bound to Phonexia's licensing server, floating license bound to local floating license server. Let's look at the advantages and disadvantages of each type. USB license is bound to special USB dongle provided by Phonexia, which must be inserted in an USB port of the machine at all time. USB license does not require any internet connection, so it's good for usage in installation which should or need to be isolated from internet. It can be useful in cases when license would be moved from one machine to another, for example when building a prototype solution on a temporary hardware and then moving it to another more powerful hardware. On the other side, it's not very suitable for virtualized environment due to potential issues with USB provisioning. Hardware license is bound to a certain hardware profile. It does not require internet connection, so it's suitable for installation isolated from internet. As opposed to USB license, it does not require any extra hardware, so it's somehow more suitable for virtualized environment. The binding to a certain hardware profile makes hardware license more secure, but also less flexible since it must be updated if the hardware changes. Hardware profile includes also network card, which is something to be taken in consideration in virtualized environments. Network license requires internet connection as the license is validated on Phonexia.com licensing server. It's worth noting here that no audio is ever sent to Phonexia. The internet connection is used only for license validity check. Audio is always processed locally. License validity check is performed periodically throughout the speech engine uptime. Network license does not require any extra hardware like USB dongle to be connected to the machine. It's also not bound to a particular hardware profile, so the same license can be in fact used for multiple machines. The only limitation is the overall number of so-called license slots consumed by the instances of technologies initialized on the machine or machines. This makes the network license useful for development machines or various testing or evaluation. Since the internet medium is generally unreliable and connection to the Phonexia licensing server may not be available for various reasons out of Phonexia's control, the network license is generally not recommended for production servers. Floating license works essentially the same way as network license, just the license is not validated on Phonexia's licensing server, but an own licensing server installed and accessible inside own network without the need to connect through internet. Floating licenses and floating license server (FLS) are suitable for high load and high availability deployments using failover clustering. The clients can be configured to validate license on up to 3 different floating license servers. If one is not reachable, client will simply try to connect to the other one. The floating license server itself needs to use either a hardware or a USB license. The client licenses are then of course network licenses. Floating license server acts as a shared license pool, which is well known for licensing of other software as well. Clients ask the server for licenses, and as long as there are free licenses available in the pool, the server issues the licenses to clients. This is something to be aware of, especially since floating license server is designed for virtualized environments where processing VMs are created and destroyed on demand. If a single client or a few clients consume all available licenses, no other clients can process the load. Floating license server is available only for 64-bit Linux. Its hardware requirements are very low, just 1 CPU and 2 GB of RAM are enough, and it should have good network connection, of course. This concludes introduction to the Phonexia speech technologies for voice biometrics and speech analytics. We went quickly over the individual technologies, their functionality and typical usages, the Phonexia Speech Platform architecture, and briefly introduced the main products forming the platform, the Phonexia Speech Engine, Phonexia Browser, and Phonexia Voice Inspector. We have shown the typical deployments topologies, the data flows in typical implementation use cases, and the technical options for licensing the Phonexia products. And here are some additional information sources. It's definitely recommended to read the documentation which is available in each distribution package in the doc folder in the form of PDF or HTML file. The changelog or news file can also provide some useful info. The command line application contain also simple example batch or shell scripts showing some typical basic usage. Running the command line applications without any parameters displays a short help with list of available parameters and their meaning. The Phonexia Speech Engine REST API documentation is available also online at download.phonexia.com/docs/SPE. The same documentation is also included in each speech engine distribution package. The partner portal available at partner.phonexia.com contains a lot of useful information. Create an account on the portal and get access to more detailed description of individual technologies, best practices, and so on. Thank you for taking the Phonexia product training. If you are ready for the next step, We recommend the Technical Training Essentials, where you get a bit more familiar with Phonexia command line applications and mainly dive deeper in Speech Engine and its REST API, its installation, configuration and basic troubleshooting, and learn to understand the results returned by individual technologies. Thank you again and bye.